Hello, ladies and gentlemen. We only have 2 more sections of trigonometry and then we're done. So this first section, or this section that we're going through today, is the law of cosines. We just came from doing the law of sines. So the law of cosines goes along the same premise as the law of sines. It's a way that we can use trigonometry to calculate distances and variables in triangles that are not right triangles. And that's really what we're going to write down for the vocab. So it's a way to write, or a way to use, I guess, cosines specifically. A way to use cosines with triangles. Mac is on my lap, so she'll probably come join us here. Use cosines with triangles. Hello, kitten cat. Can you move, please? Or am I going to need to remove you? Okay, thank you. All right, a way to use cosines with triangles that are not right triangles. So that are not right triangles. All right. And over here I have a graphic of what the law of cosines does. It's the same thing. You'll notice 3 separate lines, but it's really the same formula. And really the law of cosines is just a formula. So all we're doing in this section is going to be kind of using a formula to solve some equations. So it's separated into a law of cosines for a side called A law of cosines for the side B, and a law of cosines for the side C. But they're all the same law. They're all the same equation. So all it says is, it's kind of a play on actually the Pythagorean theorem. So A squared, this side length squared, is equal to B squared plus C squared minus 2BC cosine of angle A. And that can help us to find either the side length A or the angle A. Same thing with B. This one can help us to find the side length B or the angle B. This last one can help us, obviously, to find the side length C or the angle C. So we're going to just do some examples today, nothing too crazy, and then I will let you work on the worksheet. So first of all, here it says find AB. And these are all in like capital letters, like AB is right here, but I'm actually going to call AB side C, lowercase c, because it's opposite of angle C. So this is really side C. And that's going to help me because then I can realize, all right, which law am I going to use? I'm going to use the last one because that's the one that deals with C's. And I'm looking for this variable right here. I'm looking for the missing side C. So I'm going to take this and I'm going to say, all right, I don't know C, so I'll write C squared equals A and B in this case can be either other side. So A could be 29 or A could be 13. It doesn't matter. So I'm going to say, all right, A squared, 29 squared, plus B squared, 13 squared, minus 2 times A, which is 29, times B, which is 13, times the cosine of C, and angle C here is 41, so times the cosine of 41. You're going to want to make sure that your calculator is in degree mode when you work on these. So check that right now before you do any calculations. So here we're just going to kind of go through, and it's mostly evaluating here. So C squared equals 29 squared, which is 841, plus 13 squared, which is 169, minus 2 times 29 times 13, which is going to be 569 cosine of 41. And then we will say, all right, or actually, here, let's try that. I did it already, but I want to make sure. So 2 times 29 times 13, 754 times the cosine of 41. I put that all together. All right, and so that's 569. So there we go. And then we can just combine all of these together and we get C squared is equal to 441 if we do 841 plus 169 minus 569. And then if you take the square root of both sides, you're going to get C. So there, C is equal to 21. Most of these come out pretty close to a whole number, so I've just been rounding to whole numbers while I do it because it's like 21.005 or something like that. So it's totally okay to round to those whole numbers if you know you're really close to them. So we found this side length, C, or also AB, is 21 units long. Number 2, same thing. It says find BC. We're actually going to call BC side A, lowercase a. And so we're going to use the top law of cosines, which again is the same law. It's just moved around. So we can say a squared is equal to, and then another side squared, 30 squared plus 21 squared minus 2 times b times c, so 2 times 30 times 21, times the cosine of the side we don't know, so cosine a. All right? And sorry, we know that. That's 123. So then we can go ahead and put this all together. So a squared is equal to 900 plus 441 minus, careful with this, minus negative 686.25. Okay, and so we combine all those together and we get a squared equals 2038.25. And again, make sure that you're doing minus negative, which is adding. So we'll take the square root of both sides and we say, all right, a is equal to 45.14. All right, and that's all we have to do. Down here, we're not finding a side length anymore. We're finding an angle. We're finding angle A here. We can still use the A law of cosines because that's the one that uses angle A. But when we set it up, we're going to remember that the first part of the formula says a squared, which is the side length squared. So 14 squared is going to come first, equals b squared and c squared. So 9 squared plus 6 squared minus 2 cosine, or not cosine, wow, I'm making mistakes today, minus 2 times a times b, so 2 times 9 times 6 times the cosine of a, and we don't know a, so we're going to write cosine a. And then we figure all this out. So we've got 196 equals 81 plus 36 minus 2 times 9 times 6, so that's 108 cosine of a, since we don't know the cosine of a. And then we will subtract 81 and we'll subtract 36 from both sides. 81 minus 36, and we end up with 79 equals negative 108 cosine of a. So make sure again that you are using the negative sign that comes there. And then we want to get cosine of a on its own because then we want to find a. So we're going to divide by negative 108 from both sides. 79 divided by negative 108 is negative 0.731. That's equal to cosine of a. And then remember, if we need to find the angle and we have its cosine, we're going to use inverse cosine. So we're going to say, all right, the inverse cosine, cosine negative 1, of negative 0.731 equals, and then we're going to test that on a calculator. And this is another time where I would probably use all of the digits that were available to me on my calculator. So I'd say, all right, what's 79 divided by 108? And then I would say, all right, the cosine or the inverse cosine of that answer, just so that I can keep as many decimals as possible. And I get 42.9. Oops, I should be getting negative 108. 79 divided by negative 108. And there, so inverse cosine of that, because it's going to be different, is going to be 137. So 137 is equal to angle A, or A degrees. 137 degrees is what angle A will be. All right, and the last one here on the front, find the measure of angle B. That's different. We haven't used that idea yet because we have the angle A and we have the two side lengths here. We actually have to do 2 steps to find the measure of angle B in this problem. The first step is we're going to find side length A because we're going to need all 3 sides in order to find angle B. So let's find side length A first. We'll use the first law of cosines. So we'll say a squared is equal to b squared plus c squared, 22 squared plus 17 squared, minus 2 times 22 times 17 cosine of 143. So that's going to give us side A. So we'll put that together. So a squared is equal to 22 squared plus 17 squared. That's going to be 773 altogether. And then negative 2 times 22 times 17 times the cosine of 143 is going to be minus negative 597.3. And then we'll put those together. So a squared is going to be equal to 1,370.3. And take the square root of both sides. A is equal to 37. So right here, a equals 37. Once I have all three of my side lengths, I can go ahead and find the value b by using the second law of cosines, where it starts with b squared. So side b is over here, opposite to the b. Make sure that you're not mixing up your side lengths that you're using. So here's side b, so that's 17 squared equals the other two sides, 22 squared plus 37 squared. 22 squared plus 37 squared minus 2 times 22 times 37 times the cosine of b, the angle that we're looking for. All right, now it just goes like the same as the last example that we saw there. So 17 squared is 289 is equal to 22 squared plus 37 squared together is 1,853 minus 2 times 22 times 37 is 1,628 cosine of b. And so then we're going to simplify this. So we'll subtract 1,853 from both sides. 5, 3. And that's going to give us negative 1,564 equals, let's see, negative 1,628 cosine of b. And then to get cosine of b on its own, we're going to divide by negative 1,628, negative 1,628, and that's going to give us 0.96 equals the cosine of b. And again, this has more decimals than that. So if you're using your calculator, just keep all the decimals there. And we'll say, all right, to find angle b, we'll do the inverse cosine of 0.96, etc., that long decimal. And that is going to give us 16.26 degrees, or roughly thereabouts. So angle b is equal to 16.26 degrees. Alrighty, just one more thing. So if we turn this over, we have to use the law of cosines to solve triangles. And we can solve triangles that are written out as diagrams, or we can solve triangles, that are written out like this as just a set of numbers. So to solve this triangle, remember that means we want to find all of the angles in the triangle and all of the side lengths in the triangle. So we want to find angle A, angle B, angle C, and side A, side B, and side C. So we'll put all of those up here. And right now we know side A, side B, and side C. So A is 14, B is 9, and C is 6. So then we're just having to find angles A, B, and C. So to find angle A, we're going to use that same process as we did on the front. We're going to use the first law of cosines, the one with an A in it. So 14 squared, that's going to be on the left side of the equal sign, equals the other two squared, 9 squared plus 6 squared minus 2 times 9 times 6 times the cosine of angle A. So that's going to be 196 equals 81 plus 36 minus 108 cosine of A. Then we'll subtract the 81, subtract the 36, this should look familiar, and we end up with 79 equals negative 108 cosine of A. We'll divide both sides by negative 108, just the same process as we did before, and actually with the same numbers as we did before. And that's going to give us negative 0.73, but once again, that's a long decimal we want to keep, equals the cosine of A. And then we'll go inverse cosine of negative 0.7301, whatever that decimal is, equals, and that will give us 137 degrees. So angle A can be filled in up here, 137 degrees. Now we need to find angle B. So same process using angle B, so we'll say 9 squared, we'll start there, is equal to the other two side lengths squared. So 14 squared plus 6 squared minus 2 times 14 times 6, and then times the cosine of angle B that we want to find. So that gives us 81 equals 196 plus 36 minus 2 times 14 times 6 is 168. Cosine of B. Subtract 196, subtract 36 from both sides, and we get negative 151 equals negative 168. Cosine of B. Divide both sides by negative 168. And that's going to give us 0.898 and some more decimals. Keep that whole long decimal in your calculator. And that's going to be equal to the cosine of B. Then we'll go in here and say, all right, what's the inverse cosine of 0.898, longer decimal than that? And it's going to say, well, that's 26. So angle B is 26 degrees. And you might be saying, we need to do this again. Or you might be saying, no, we don't, Miss Goring. Remember, the triangle has 180 degrees in it. So we can just say 180 minus the 137 for angle A minus the 26 for angle B. And then we can find out that angle C needs to be 17 degrees. So angle C is equal to 17 degrees just by subtraction. We don't need to use the law of cosines again. All right, and that is our triangle solved because we have all of the measurements that we need. All right, so a pretty straightforward section, actually a very heavily algebra-based section. You'll probably see this again in Algebra 2, but you'll be super prepared for it now. So go ahead and work on the worksheet for this one, and let me know how you do. All right, have a good day.